We usually picture black holes as cosmic vacuums, static spheres of dark gravity that sit in the center of a galaxy and slowly pack on weight. The heavier they get, the further along in their life cycle we assume they are. This chart compares two specific black holes to test that assumption. On the right is the famous black hole at the center of the galaxy M87. On the left is the black hole inside galaxy NGC 1277. It weighs in at roughly 17 billion times the mass of our Sun, nearly 3 times heavier. But despite that massive weight advantage, cosmologists actually rank NGC 1277 lower on the cosmic evolutionary ladder. Under this taxonomy, a black hole's status is not determined by its sheer mass. Instead, it is defined entirely by its merger rank, exactly how many rival black holes it has swallowed. To understand the ultimate fate of the universe, we have to stop looking at black holes as isolated objects. We need to view them as active competitors in a 4-step cannibalistic elimination tournament. The tournament begins at level 4, raw matter. Before a black hole even exists, gravity draws loose gas, dust, and stars into incredibly dense clusters. We can observe this pre-hole stage right now in the nearby Triangulum galaxy, or M33. Its center is packed with a dense cluster of stars pulling everything inward, but measurements show the mass of an actual black hole there is consistent with 0. The arena is built, but the gladiator hasn't spawned yet. Once that matter condenses far enough to seat a central black hole, the galaxy advances to level 3, the base state. Our own Milky Way, with the Sagittarius A star black hole at its center, is a standard level 3. In the grand cosmic tournament, we are currently a mid-level player. To climb to level 2, a black hole must become what cosmologists call cluster dominant. It achieves this by physically devouring its neighboring galaxies and absorbing their central black holes. This brings us back to M87. It is a level 2 champion. It earned that rank by successfully cannibalizing its neighbors, which is exactly why it outranks the heavier but unmerged NGC 1277. A black hole's position from level 4 up to level 2 provides a direct historical record of its victories in a localized battle royale. But the latter is a two-way street. Losing a merger can violently eject a black hole from its home galaxy entirely. This happens through a mechanism called gravitational wave recoil. When two black holes spiral together and merge, they can emit uneven radiation. That asymmetry acts like a rocket thruster, delivering a superkick that launches the newly formed black hole into deep space. We actually see candidates for this in the wild. The quasar 3C186 is a supermassive black hole found physically offset from the center of its host galaxy, wandering as a rogue after being kicked out, which presents a mechanical problem. If merging creates these massive superkicks, how do the level 2 champions eat so many rivals without being thrown out of their own clusters? The answer is a mechanical shield, spin down. When a champion absorbs smaller rivals from random angles, those conflicting trajectories grind down its overall rotation. Because superkicks require high spin, these sluggish behemoths become mathematically immune to the recoil. Smaller holes get kicked, big ones survive. The brutal, cannibalistic nature of the climb naturally protects the biggest winners. It grinds down their spin and locks them safely in the center of their clusters for the final round. That brings us to the top of the hierarchy, level 1, the survivor. This is a black hole that has successfully consumed every single neighbor and gas cloud within its gravitationally bound island, leaving it completely alone. While we have distinct real-world examples for levels 4, 3, and 2, we do not have a single picture of a level 1 survivor. That blank spot in the catalog is due to the observer's window. We live right in the middle of the cosmic timeline, surrounded by active star formation and ongoing mergers. A true level 1 survivor will only exist in the unimaginably deep future, long after all local mergers have completely ceased. Once it achieves total isolation, the survivor sits quietly. Over eons, it slowly bleeds away its mass until it dies in a single massive flash of Hawking radiation. So when we look up at the Milky Way or M87, we aren't looking at a peaceful, static sky. We are looking at a mid-game snapshot of an unyielding tournament, one that will leave only a few isolated, evaporating survivors alone in the dark.